going to be an instructional video on PCR. I call it my PCR Bootcamp. As you know, with PCRs, there are a lot of problems with contamination. You know, the ideal thing is to have separate rooms to do all the separate procedures, but that's just not going to be possible in a research laboratory. So what we do here is we do our work all in a laminar flow hood, such as this one. This one happens to be a Class 2 Type A2 hood. So something like this is very useful. You can do everything in here, but you know, most important thing is cleaning it and keeping things separated. So during this video, I'll just try to show some ways to, you know, try to minimize contamination, some hints that you can use, and maybe you'll have a successful PCR that's contamination. First thing that we need to do is we need to clean up our hood. For cleaning inside the hood, we first use a 10%, this is called back down solution, which is basically 10% detergent. We wipe down the surfaces with that, allow it to, you know, wipe it dry, and then after that we will go over it with 70% ethanol, which whole purpose is just to make sure that everything is dry and that the hood is not wet. I also will, if there's any trash there from the previous day, I will take those out and put in brand new trash, and that just prevents possibilities of contamination. So what I do is I work my way from outside to inside. So out here, I'll just use 70% ethanol just to kind of wipe everything down, because I mean, you don't know who uses the hood, and people can be grabbing the back of the chair with dirty gloves. It just, anything possible just to minimize that contamination, because we don't have that freedom of, you know, having separate rooms for everything. So here I just take for a gauze pad or whatever it is that you have, spray, you know, my surfaces with ethanol and just wipe it down, clean it up. And with that, I will also spray the hood part, because this is where I'll be putting my ice bucket, my pads, anything that I may need to use. I want to make sure that it's wiped down. If this one happens to have like a little pad over here, I've already changed this, so you probably want to make sure that that's also clean and not contaminated. And now I'll work my way inside the hood. Here's the 10% detergent solution. Just squirt it out there a little bit, some of my gauze pad. And then work my way from outside to inside, because outside is probably going to be the cleanest part. And then work your way to inside. That way you could use the same gauze pad or just same towel, whatever it is that you're using. So just make sure that you wipe everything down. I'll take these trash out, get rid of them. Okay, and once I've done my detergent, then I'll take the ethanol, 70% ethanol, and kind of try to pick the detergent off the surfaces. So same thing, start from the outside and work your way to the inside. So now, and just to make sure that it's clean, you don't have any, you know, contaminating reagents or DNA in there or any template, I'll UV the hood for at least 10 minutes. Don't really need it longer than that, so we'll do that right now. UV it for at least 10 minutes. So we'll let that UV and we'll come back when it's done. Okay, so now that our hood has UV'd, we're ready to set up our PCR. What I also do actually, and I didn't show earlier, is you could actually leave your empty PCR tray in there and UV at the same time as you're UVing the hood. The other thing too is with my PCR tubes, my bag, I don't open my bag except for inside the hood. I don't ever open it outside, because that way I don't you know, take any unnecessary risk of my tubes getting in contact with anything that's going to contaminate my PCRs later. So the hood is a little small, so sometimes the movement that you're going to have to take is a little awkward. But the point is to try to keep your tubes safe. My rule is to always do all the clean stuff, set up the reagents and everything first before you actually introduce the template. In this laboratory, we also have 2 sets of pipette. We have our what we call our clean set, which we only use for reagents. It never ever sees template, although we use filter tips for everything that we do. And then we have a dirty set that we use for everything else, but not the PCR reagents, okay? So as you take, I've already wiped down my pipettes and my tips with some 70% ethanol before I take it into the hood, just to make sure that everything stays clean. So we're gonna bring in my ice bucket, and we're gonna work from here. I set up, in the meantime, these are my empty tubes ready for PCR. I'll put it in the back so I don't, you know, do anything that's gonna contaminate it. Have my waste on this side. So the number 1 rule is people make the mistake of putting an open box of pipette tips in front of where they're gonna dispose the waste. That's not a good idea, because on your pipette tip, I mean, you don't know what's in there. You could have droplets falling into your open tips and later on contaminating it. So although in my case I'm, you know, right-handed and it's a kind of awkward reach because I have to cross over my body this way, I put my tips on this side and my waste on that side, and I don't put anything that I need to use in front of my waste. So the path to the waste is always clean. So I'm just gonna start putting together my reagents. Like I said, I start with the clean stuff before I start to introduce the template. So the very first thing I do is, when I'm making my master mix for PCR, is I will add the water first. Because that way, if I make a mistake, you know, it's easier to replace the water than to replace anything else in the PCR mix, right? So we're gonna add the water first, and I set up these tubes for my master mix. Always be aware of where a used tip crosses over. You don't want to be sitting around after you use a tip, although we're just using reagents now, but it's just good to be aware. I don't want to use it and then suddenly turn around and talk to people and my tip that I've used for something is waving everywhere. So that's something you don't want to do. Always be aware of that. Add in my water. Next thing is I'm going to just continue to add the remaining reagents I need to make my master mix. Possible, I try not to leave my tip box open. If I could just open it, remove the tip that I need and close it back, I prefer it that way. If it's easier for you, you can leave it open, but make sure that it is in a safe place. Don't leave it open and then decide to use the vortex, because really the vortex little particles can be flying everywhere and they'll get into your tip box. Nothing I'm doing right now is biohazardous, although I'm disposing everything in the biohazardous waste, because that is how we do it in our laminar flow hoods. So it's okay. I mean, I'm not gonna go out and dump all my tips in a regular way. So we're just gonna do everything as if I'm just working in a biohazardous zone. Still continuing to add everything that we need, so almost there. Adding my primers to my master mix. I have 2 different master mix I'm setting up right now because I'm doing PCRs in 2 different regions. So normally in your case, if you're doing PCR for one region, then you'd just be setting up the one master mix. You always want to give your reagents just a quick vortex too before you add it. Just make sure everything is mixed. If you also notice, as I'm adding my reagents, once I've added it, I take it from one spot on my ice bucket and put it into the other spot on my ice bucket. That kind of helps you, in case you get distracted and you forget what you just added. That way you could, keep track of what's been done and what hasn't been done. It'll minimize mistakes that you might make when you're setting up your PCRs. So the very last thing I do when I'm setting up my PCR is I add the Taq polymerase. Now the Taq polymerase I do not vortex. I will just mix it by flicking it and then adding what I need to add. If you drop a tip like that, don't use it, throw it in the waste. So now everything is in our master mix. I'll just give each one a nice light vortex to just make sure everything is mixed. I will take it out of the hood and give it a quick spin, and then we'll go from there, because I want to make sure I only made enough volume for one extra. So I want to make sure that I'm able to take out what I need to set up my PCR. So I'll just give it a quick spin. So I'm back from giving my tube a quick spin. Before I turn it into the hood, and I stuck it in a centrifuge to give it that spin. Swipe it down a bit, make sure everything is clean. I will also change my gloves because I've been out of the hood. Just want to make sure that everything stays clean. So now I can add the master mix to my PCR tubes. First, and for the PCRs that I do, everything is set up on ice because that prevents any non-specific reaction going on before you get into the thermal cycler. It all depends on the primers that you're using, the polymerase that you're using, but in our case we set up everything on ice. So I'll add the volume that I need for the master mix first into all my tubes, and as I mentioned before, I have 2 sets of tubes because I'm doing 2 different regions. So at this point, I will usually just keep the caps open. That way it's easier for me to go through each one. All right, but just make sure that once your cap is open that you don't cross your hand or your glove or your sleeves over the open cap. Try to stay clear of it. Stay away from it. If you're going to cross and reach in the back, make sure that you don't go over the open tube. So I'll just go over here and get my mix. Give it a slight mix. At the cap, I'll just put down in the back somewhere over here. I won't be needing it after I add my mix, but just want to make sure everything is stay clean. And so I put master mix into each one, and as I add the master mix, I cap it. You can see what I did with the first set, with the other set that I'm working with right now. But I always make sure too is once I put my master mix in all the tubes that I need, that I check the tube where I made my master mix in, just to kind of double check that my volumes and my pipettes are accurate. So I set it up for 1 extra, so when I pipette out, I should have only enough master mix left there for 1 extra or a little less. And that way I know that I didn't make any mistakes, that more than likely everything was added in there correctly and my pipettes were calibrated, all right? So we'll do the master mix for this other set right here. And this one we could see, you'll see what I did. So leave the caps open for the tubes. Give that just a little bit of a tap on the vortex. And what I do, you can use the same pipette tip for all. In my case, I only have 4 tubes, but sometimes I don't like to do that because when you're using one, you need to make sure that there are no bubbles in there, that you're ejecting the correct volume, that the tip is just not all over the place. So in our case, because we want to make sure that everything is done correctly, we just change tip in between each one. But of course, if you're setting up a lot of tubes, it's sometimes cost efficient for the laboratory to use the same tip, and you can use that. Just make sure, like I'm doing right now, is that you're aware of where your tip is going, where it's going to, and where it's coming from. So see, it works that way too. And then I just cap everything. And we're gonna check and make sure that I have the volume that I expect to have, and I do. There's only enough left there for 1 extra, so we'll dispose of that. So now that we've added all the clean reagents and everything else, we are ready to put in our DNA template. So for this one, I switched to what we call our dirty pipettes. It's the pipettes that we use for everything else, but not our PCR reagents. I'll switch with that. And we also, have a set of clean tips that go with our clean pipette, and then we have our dirty tips that go with our dirty pipettes. So I will now add each of the template into the correct tubes individually. So I have 3 samples actually for each region, and the last one is my negative control. I suggest that you do your negative control last, because doing it first is almost cheating yourself. I mean, if the negative comes out negative, how do you know that you didn't contaminate anything along the way if you work with that negative control last? So I just treat it like I would normally. So we'll start with adding my template to the tubes. Make sure that I grab the right ones. So each DNA sample is going to go into 2 different tubes because I'm testing for 2 different regions. And at this point, I can leave my tip open. Careful not to go across that way. Take the volume of DNA that I need for my reactions and put it in my tube. And since this is a large volume, I just pipette up and down to mix it. Make sure that there are no bubbles in the middle of the liquid or in the bottom. The bubbles at the very top is okay, but if you have bubbles that are in the middle or in the bottom, somewhere in that area, that could inhibit your PCR reactions, depending on how big the bubbles are, okay? So the same sample is going to go in the other tube for the other region. And then last, but very important part of PCR is my negative control. So I have master mix and my negative control. I will just be adding water to it, the appropriate volume to make up the final volume. So with that, of course, I'll use my clean pipette tip. So the negative control tells me that if I see bands, PCR bands in my samples later on and my negative control is clean, is basically none of my reagents were contaminated. We don't normally run a positive control in this laboratory unless we're just beginning to work on a particular region and we know nothing about it. But once we get everything established and optimized, whenever we set up our PCRs, we assume that the samples that we're doing PCRs on should all be negative. Should all be positive. So negative control is all you need. If we continue, however, to have problems and we don't see PCR products, then we may have to go back and introduce a positive control. But for now, I think the standard negative control is better for you, because if you're always having to put a positive control in there, the chances of you contaminating your samples with your positive control, gets greater. So I will just add the same water that we use to add the master mix to our negative control. You want to make sure you use the same water, because if you don't, how are you going to know that the water that you use in your master mix is okay? Besides pipetting up and down, you could just, once you add your template, give your PCR tubes a little bit of vortex to mix everything in there. I prefer not to do that because I don't really like to take the extra step of doing a quick spin just to get everything to the bottom. But for you, if it works better, then do it your way. But now I'm ready to go. My sample should be mixed into the PCR tubes. I check everything and make sure that there are no bubbles there, that everything is clear, and then we can put it into the thermal cycler. However, if you notice that you have a lot of liquid up the sides here, or you have a bubble in there, then please give it a quick spin so that you make sure that all the liquid is in the bottom, okay? So we're gonna go into our hood, and I normally, before I go out, since I've been handling also DNA template in the hood, just to try to keep everything contained and I'm not scattering things all over the laboratory, I do change my gloves to a clean pair before I take everything out. Alright, so now that everything is ready, we'll just go into the thermal cycler. We're not using a hot start Taq polymerase. Those usually start at a higher temperature, and activity you don't get activity out of the Taq until you've denatured it. We're just using a regular Taq. So what I like to do to also try to prevent any non-specific products is I'll give the method a start, wait for it to get, I'm starting out at 95 degrees. I wait for it to get at least to 90 degrees or somewhere in the 80s, pause it, and then put my PCR samples in and then start the reaction. I don't want to let it sitting there too long. So it's kind of like a fake hot start, if you might want to call it that. So I'll just pause it right now. It gives me the opportunity to put my samples in there. And as you can see, I don't try to separate my tubes. I mean, I'll put them one here, one here, one there. If you're really careful about setting up your PCRs, you shouldn't have to worry about separating your tubes. They're tightly capped. They're safe. So now you just resume and then the program starts and off we go.
There you go, it's recording now. Okay, it's recording now. Okay.
So first we'll wipe down with the back down. We use 4x4 gauze pad. You can use whatever you need to wipe down your hood. Cut.
Should we say that or we should This is for the bloopers.
Oh my god!
Look, we're gonna send Jamie all the bloopers.
Okay. You can cut for a while. While we quick spin. Ay, caramba. Ay, caramba. We'll come back later when the PCRs are done. I got it in. Yay! Now I'm gonna do gag. Do I have time to do gag?